Hi everyone. In this video, we will go through Cauchy's integral formula, which is a key statement in complex analysis. It implies that a complex function defined on a disk is determined entirely by its values on the disk boundary. For all derivatives of a complex function, it provides integration formulas. In this video, we will learn Cauchy's integral formula and the formula with help of this particular problem. Basically, what is Cauchy's integral formula? If a complex function f of z is analytic inside and on a closed curve C, if A is any point inside a closed curve C, then integral over C f of z by z minus a dz is 2 pi I times f of z at the point z is equals to a. This is the statement of Cauchy's integral formula. You need to remember this particular integral formula to solve various complex integration. Cauchy's integral formula for the derivative of an analytic function. If a complex function f of z is analytic in a region, then its derivative at any point z is equals to a of the region is also analytic in the region, and it is given by integral over c f of z by z minus a power n plus 1 dz is 2 pi I by n factorial times nth derivative to the complex function f of z at the point z is equals to a. This is the generalized Cauchy's integral formula for the derivative of analytic function f of z. This is also very important for all competitive examinations apart from main examinations. Now we have to evaluate integral over c z plus 4 upon z square plus 2z plus 5 dz, where c is the circle. To tackle this type of problem, we must know Cauchy's integral formula. Therefore, Cauchy's integral formula can be utilized to solve this type of problem. Generally, we know that if a complex function f of z is analytic within and on a closed curve, and if z is equals to a is any point in the middle of the curve, then we have the formula integral over c f of z by z minus a dz is 2 pi I times f of a. Based on this formula, we need to identify what is the function f of z and also what is the point a that lies inside a closed curve C. For this, let us assume that integral over c z plus 4 by z square plus 2z plus 5 dz is I. To get the singular points, making denominator is 0. Therefore, the singular points are given by z square plus 2z plus 5 is equals to 0. It is a quadratic equation in z. It is compared with az square plus bz plus c is equals to 0. We have a is 1, b is 2, c is 5. The roots are z equals to minus b plus or minus root over b square negative 4ac by 2a. It gives us negative 2 plus or minus I4 by 2 in the simplest form, negative 1 plus or minus I2. We have obtained two singular points. They are negative 1, negative I2, negative 1, positive I2. Verify whether which singular point lies inside a closed curve and which singular point is lies outside the closed curve C. Here we are given that the curve C is the circle with center at -1, -1 and radius of 2 units. We have the first singular point -1, -2i. We have modulus of z plus 1 plus I. Consider this thing. We obtain the result is less than 2 or greater than 2. Why? Because we have the radius 2. After consideration, the radius is less than 2, the point lies inside C. In case the resultant radius is more than 2, the point lies outside the closed curve C. So modulus of z plus 1 plus I is modulus of -1, -2i plus 1 plus I. Just we have substituted z with -1, -2i, we get modulus of -i. We know that modulus of a plus ib root over a square plus b square. Here a is 0, b is -1. So root over 0 square plus -1 square is only 1. This is the radius. So 1 is less than 2. That means the point lies inside a closed curve C. The second point, -1 plus 2i. Let us consider modulus of z plus 1 plus I, where z is -1 plus I2. On simplification, we have obtained modulus of I3. So modulus of I3 means root over 0 square plus 3 square, that is only 3. 3 is more than 2. Hence, the point z equals to -1 plus I2 lies outside a closed curve C. So based on this information, let us assume that f of z be z plus 4 by z plus 1 minus I2. So based on Cauchy's integral formula, here f of z is analytic inside and on the closed curve C. We have integral over C z plus 4 by z square plus 2z plus 5 dz is integral over C z plus 4 by z plus 1 minus 2i as the function f of z, and the denominator we have z negative a, that is z plus 1 plus 2i dz. By Cauchy's integral formula, we have integral over C f of z by z minus a dz is 2 pi I times f of a, which implies that integral over C f of z z plus 4 by z plus 1 minus 2i by z plus 1 plus 2i dz is 2 pi I f of z, this thing z plus 4 by z plus 1 minus 2i. So only the point -1 minus 2i lies inside the closed curve C. So we measure the function value at this singular point. We have 2 pi I times z replaced with -1, -2i. We obtained this expression. On simplification, we have 2 pi I times 4 -1 3 -2i, -1 positive 1 cancelled. In the denominator we have -4i. So on simplification, I cancelled, and we have pi by 2 times 2i -3, which is the required result to the complex integration over the closed curve C by utilizing Cauchy's integral formula. This method is very important for all examinations.